Ever found yourself looking at just a massive piece of machinery? Maybe a shaft thicker than you can reach around, or some huge bolted down industrial giant?
Hmm.
And the only thing you need is a simple keyway, maybe a slot, or just a flat surface machined onto it.
Yeah, and suddenly that simple job feels, well, impossible almost.
Right. Because you're dealing with gear that's just way too big or maybe too integral to just pull apart and haul off to a machine shop.
It's a really common headache in heavy industry. The whole traditional process, disassembly, shipping, shop time, reassembly. It's not just a logistical pain. It can seriously drain time and money.
Totally. And that right there is what we're getting into today.
Yeah.
We're exploring these portable Keyway milling machines, basically machines that bring the workshop right to the problem.
Yeah, think of it like a mobile machine tool. And they cover quite a range, don't they?
They do, from, fairly small shafts, maybe 3/4 of an inch, up to those really big ones like 2 feet across.
Now, I know what some people listening might be thinking, especially if they're used to, high precision workshop environments. Can a portable machine really deliver the goods, the accuracy, the finish?
That's the big question, isn't it? Can something you clamp onto this enormous static piece of metal
Mm-hmm.
really give you workshop level results?
It's a fair question.
And the short answer is maybe surprisingly yes. High accuracy, really good surface finishes. It's achievable, and we're going to unpack how they manage that.
Okay, let's dive into that precision aspect first because it is critical. For things like keyways or slots, you need tight tolerances for a proper fit, good surface finish for longevity.
Right.
And these portable units can often achieve finishes down to RAW 1.6, which is, well, it's a pretty smooth finish for this kind of work.
RAW 1.6
Yeah.
on site. That is impressive. So what's the magic behind that? It can't just be luck.
No, definitely not luck. It really boils down to, well, two main things: clever design and careful operation. These machines incorporate precision parts you'd find in bigger stationary mills.
Like what specifically?
Well, for instance, they often use ground dovetail ways, those V-shaped slides.
Ah, okay. For smooth travel.
Exactly. Very smooth, but more importantly, very accurate movement for the cutting head. Then you've got calibrated dials, often marked in tiny increments like thousandths of an inch, for really fine depth control.
Got it.
And the lead screws that drive the movement, they're usually high-quality Acme threads, often with roller bearings, to keep everything precise and backlash-free.
So they've essentially packed the critical precision bits of a workshop mill into a portable package.
Mm-hmm.
But I guess how you attach it, how you set it up, must be vital if it's wobbling.
Oh, absolutely fundamental. Rigid mounting is non-negotiable. Vibration is the absolute enemy of precision machining.
Right.
That's why the clamping systems are so robust. We can get into those specifics in a bit. But beyond just the machine, getting that top-notch result also depends on how you use it.
Like technique.
Yeah. Consistent feed rates are crucial for a good finish, whether you're feeding manually or using a power feed attachment. And of course, using the right cutter, sharp and appropriate for the material. HSS or carbide makes a world difference.
Standard machining best practices, basically.
Yeah,
And operator skill, I imagine.
definitely. A skilled operator who knows how to align the machine properly using dial indicators, levels, and understands how to take the right depth of cut, that's key to unlocking the machine's full potential.
Okay.
Look, it's not going to be the, sub-micron precision you get from a massive CNC in a controlled lab, but for probably 99% of industrial keyways, slots, flats, the accuracy is absolutely there. It meets the need right where you need it.
All right, so they can be accurate. We've established that. Now, where do these portable wonders actually, earn their keep? You said heavy industry. Give us some concrete examples.
Sure. I mean, fundamentally, they're used anywhere that moving the equipment itself is just too difficult or costly for on-site maintenance. Think about mining and construction first.
Okay. Big yellow machines.
Exactly. Repairing a shaft on a huge excavator or a rock crusher, big conveyor belts, drills, doing that right there in the field. It avoids massive downtime, saves a fortune. Just imagine trying to ship an excavator boom somewhere.
Yeah, that sounds like a logistical nightmare. For sure. What about other sectors?
Shipbuilding is a big one. Propeller shafts, rudder stocks, engine parts, winch drums on deck.
Huge components.
Huge. Being able to machine those right on the ship, maybe even while it's still afloat sometimes, avoids the crazy expense and time of dry docking just for that specific job. It turns weeks into days, potentially.
Wow. That's a serious impact.
And power generation, too. Think turbines, generators, massive pumps. They all have large shafts or casings.
Critical stuff.
Very critical. Doing precise machining on-site during a planned outage, or even more importantly, during an unplanned breakdown, means getting back online faster. Less lost revenue. An hour of downtime on a big turbine can cost, well, a lot. This can fix the issue within hours sometimes.
Literally keeping the lights on in some cases.
Yeah.
Any other areas?
Yeah.
Manufacturing plants.
Oh, yeah. General manufacturing, industrial settings, repairing shafts on fixed machinery, maybe adding a modification after something's already built, working on large machine bases. It just gives you flexibility, minimizes stopping production.
Right.
And think about process industries, pulp and paper, steel mills. They have critical process lines with roll journals, gearbox shafts, conveyors. If one of those goes down and needs machining, stopping that line has massive knock-on effects. Portable milling gets it fixed fast.
Okay, so the common theme is definitely big, heavy, fixed, or super critical parts that need a keyway, slot, or flat.
You've got it. If the thought of moving the component makes your head spin and your budget cry, portable keyway milling is probably the answer.
All right, so they tackle these massive jobs, but how do they actually, stick there? How do they stay stable enough to cut accurately? It can't just be a couple of G-clamps, right?
No, definitely not G-clamps. Stability is everything, like we said. The mounting relies on really robust clamping systems designed for different shapes. For shafts, the most common is probably V-base clamping.
Like a V-block.
Exactly. The V shape naturally centers the machine on the round shaft. For smaller shafts, you might use strong bar clamps. But for the really big ones, up to, say, 24 inches or even more, they often use heavy-duty roller chain clamps.
Chains, okay.
Yeah, like a big, strong bicycle chain, but industrial scale. It wraps around, pulls the V-base super tight against the shaft, gets very even pressure. And some designs are clever. They don't even need much shaft sticking out. Maybe only 1.5 inches sometimes to get a solid grip.
That's pretty smart. What if it's not a shaft, though? You mentioned flats and slots.
Right. For flat surfaces, if they're ferrous iron or steel, powerful magnetic bases are fantastic. Super quick, really secure, just flick a lever.
Like a mag drill base.
Similar principle, yeah.
Yeah.
Just need a clean surface for the best hold. Or if you're working on something like a flange face with existing bolt holes, sometimes you can just bolt the machine base directly down. That's about as rigid as it gets.
Maximum stability there.
And there are other adapters, too, for clamping onto flat plates or edges if needed.
So quite a few options, depending on the job. But just clamping it on isn't enough, is it? You've got to get it lined up perfectly straight.
Oh, absolutely critical. Before you even think about cutting, you spend time on alignment, using dial indicators, precision levels, squares, making sure the cutter path is perfectly parallel to the shaft axis or square to a face, whatever the job requires.
Right. Setting it up right is half the battle.
It really is. And here's another neat design feature on many of these. Sealed lubrication systems. Meaning they can run in pretty much any orientation, horizontal, vertical, even upside down. The lubrication stays where it needs to be, which is a lifesaver in awkward spots.
That is handy. No oil dripping in your face while you're working overhead. Okay, so accuracy.check, secure mounting.check. Let's talk about the bottom line. Downtime and cost. How do these machines really deliver those big savings we talked about? Because downtime, especially in these industries, is just killer.
The impact on downtime is, it's probably the single biggest benefit. By bringing the machine to the job, you just eliminate that whole chain of events for off-site repair.
Right. No disassembly, no transport.
Exactly. No complex disassembly, no crating, no heavy transport logistics and costs, no waiting in line at the machine shop, then no transport back, no reassembly. Just cutting out those steps saves enormous amounts of time. Weeks can genuinely become days, or sometimes even just hours.
That's huge.
Yeah.
So massive time saving just from avoiding the logistics. But the costs go beyond just saving time, don't they?
Oh, absolutely. Think direct costs. You save all the labor for disassembly and reassembly. You save the transport costs, rigging, cranes, special trucks that can be incredibly expensive for large parts.
Yeah, I bet.
But probably the biggest saving, often, is the reduction in lost production. Keeping that plant running or that ship sailing or that mine operating, that's where the really massive financial benefits are. Less downtime equals less lost revenue. Simple as that.
And faster turnaround overall.
Much faster. You can often start the job almost immediately, get it done quicker than waiting for shop availability.
Fewer headaches all around, it sounds like. Any other, maybe less obvious economic pluses?
Well, yeah. You reduce the risk of damaging something else during disassembly or transport. That happens. Unexpected costs, more delays.
Good point.
And just looking at the investment itself. buying one of these portable millers, the cost might be similar to just one major offsite repair on a really big piece of kit.
Seriously, one repair could pay for the machine.
In some cases, absolutely. Then, once you own it, every subsequent on-site repair is basically pure savings compared to the alternative. Plus, they come in different power options, electric, pneumatic, hydraulic, so you can usually run them wherever you need them.
That makes a lot of sense. It's moving from a big reactive expense to a proactive capability that pays for itself over time.
Precisely. Think back to that example of a big press gear needing a new keyway. The cost to remove it, ship it, get a machine, ship it back, reinstall it. Yeah, that could easily buy you a very nice portable keyway miller, and then it's there for the next job and the next.
It really does make a compelling case for bringing the machine shop to the workpiece. Okay, so as we wrap up this deep dive, what's the main thing you want people to take away about these machines, especially if they're wrestling with those huge, immovable machining jobs?
I think the core message is that portable keyway milling machines aren't just some niche gadget. They're really an essential tool for anyone needing precise on-site machining, keyways, slots, flats on large or fixed equipment.
Right.
Their ability to deliver that workshop-level precision right where it's needed, it fundamentally changes the game for maintenance and repair.
Yeah.
It slashes downtime, cuts costs dramatically. They're just incredibly valuable across so many heavy industries.
A true game changer for those previously impossible tasks. So were you listening? Here's something to ponder. How could bringing this kind of machining capability directly to your biggest, most stubborn, immovable challenges change your maintenance strategy? What could it unlock in terms of efficiency? What on-site repairs that seem out of reach right now might actually be possible? Definitely food for thought.